So in this problem, we're shooting up a toy dart with a launcher that has a spring compressed in it, and the spring constant is 140 newtons per meter. We can compress the spring different amounts in 0.02 meter intervals, anywhere from not compressing it at all the way to compressing it 10 centimeters. We launch the dart directly upward, and so what's happening is the elastic potential energy stored in the spring is going to become gravitational potential energy when the dart's at its maximum height. And so to figure out what I can graph from this data to get a straight line, I want to look at the formula that 1/2 kx squared is going to equal, this is the elastic potential energy stored in the spring, eventually becomes the gravitational potential energy of the dart. Now we use y for h, and I want to get this into y equals mx plus b format. So the thing that I'm altering in my experiment is this x squared, and the y is the dependent variable, the height to which it goes to. So I'm going to get the h alone, and I'm going to call it y. And so I get k over 2mg, and I'll put my x squared over here. So what this tells me is if on the y-axis I put the height the dart goes to, and if I put x squared on my x-axis, then the slope of the best fit line, which will be linear, is going to be k over 2mg. So over here, I'll put an x squared, and my values will be 0, 0.0004, 0.0016, 0.0036, 0.0064, and 0.0100. Now when I graph these, it's going to be hard to graph such small numbers. So maybe instead of doing this, I should do x squared, but instead of having it in meters squared, I'll have it in times 10 to the negative 4 meters squared. And that might make it a little easier for me to graph, because all these numbers are a little bit more reasonable. This is not required, but it might be a good idea. So here's how I set up my graph. On the y-axis, I put the height that it attains in meters. On the x-axis, I put how much the spring was compressed in times 10 to the negative 4 meters squared. I'm sorry, this should be x squared. You can see it gives me a nice straight line when I plot my points, and my best fit line would look something like this. You should use a straight edge or the side of your test in order to make a nice straight line. In this question, we are to explain how the slope of the best fit line could be used to determine the mass of the dart. We can use equations, but we also must use words. So the first thing you want to explain is that the potential energy that was stored in the spring eventually becomes the gravitational potential energy of the dart. And so 1/2 kx squared is equal to mgy. And so since x is the variable that we change, that's the independent variable, and y is the variable that changes because of what we change, that's the dependent variable, I want to get the y alone, and so y is equal to k over 2mg x squared. So I would write this on the side. Now I'd start writing my pros. First thing I'm going to make sure I write is a statement that says the potential energy stored in the spring becomes gravitational potential energy. Second thing I would write, I'll make this into an equation that fits the form of the equation of a line. Third thing I'll write is that the slope of this line, according to the formula y equals mx plus b, must be equal to k over 2mg. The fourth thing I'll write is that we know that k is 140 newtons per meter, and we know that g is 9.8 meters per second squared. So if we find the slope, we can just plug it into this equation and solve for m.